Probably shouldn't hardly ever have to adjust that, huh?
Whenever the more you increase here for your drive
Oh,
belt tension,
yeah, that's when you do that. Okay.
yeah,
Gotcha.
you'll have to compensate and lower that.
Okay.
There we go. You can move it if you push it hard.
Right.
Yeah, these brake straps are normally a little bit of a pain. Once they wear in, because if those bands aren't, formed perfectly
Yeah.
to this drum, if they get, sprung back a little bit, they don't grab that great.
It's probably about, pulling on that, it's about 20 pounds of pressure, something like that.
Okay, let me put these covers back on. Actually, while we got these covers off, I'll go ahead and point out a couple things to you. I don't have anything long enough to point to it, but see right down there on that pillow bearing, there's a grease zerk fitting that's facing out towards us.
Kind of see it. You see it, Dad?
See it down in there. It's a real pain to get down in there and get to it.
Black, ain't it? Right now?
Yeah,
So,
yeah,
okay.
it's got black grease on it.
Okay. Yeah, right there.
And then there's another one. You can't really see. It's going to be right here. So you can kind of see that there's a shaft right here that's welded to this bracket.
Yep.
There's a grease zerk fitting on this shaft right behind this
Back
bracket.
side. Okay. Okay. You do a video. Y'all ever equip these with electric motors instead of gas or diesel?
Yeah.
You can? Okay. Didn't know that. I was just curious about it. Those cost more or?
It costs about
less?
the same as the diesel, yeah.
Okay.
Both of them are an upcharge compared to the gas. The gas is what comes on standard.
Okay.
I think the diesel's quite a bit of an upcharge.
Right. So how does the electric work? I mean, is it made for attaching it somewhere, or do you run a?
Yeah. So you would want to run some sort of a festoon trolley system with
up above hanging,
Yeah.
and then have your cord just
Yep.
going in. Okay.
Yep.
So the electric wouldn't be made for mobile and
Yeah,
moving
no,
around.
not really.
Gotcha. You could have put an electric one on this if you'd wanted to.
No,
They are quieter.
you get 3-phase up in there then.
Oh, it has to be 3-phase.
Yeah.
Okay, I got you. All right. Easier to put it back on than take it off.
Yeah. This time.
What do you think, Dad? Anything new? Or you remember it all from last time?
Shit, I don't remember. I never had any trouble though, really.
Yeah.
Put a battery in it. All you had was holes. You had to fit the closest hole to the, when you let them down.
Mm-hmm.
I had to put little pads on the certain places. Make it level up.
Okay, so I'm gonna go ahead. Pull these covers off. Not really a whole lot to see underneath here, but I like to take them off anyway so you can see. So here's that center track cover with the piece of felt. So I'm going to go ahead and saturate that with some automatic transmission fluid. So these cam follower covers here are basically just to protect our rollers. And then on the outside there's a white wiper that's basically just to keep debris from getting inside here. So periodically you'll want to take these covers off. Blow this out because it'll collect some sawdust. And then you could roll the carriage back and forth just to verify that your rollers are still rolling like they should and you don't have seized bearings. You can also use a pry bar underneath here, just kind of put a little bit of pressure on it, and then you'll be able to spin these bearings by hand to get a feel for them. Same thing underneath this cover here, white wiper on the outside, and then cam follower bearings underneath it.
Better than the other one. The other one didn't have as good a wiper there.
Yeah. That'll help keep it clean, keep the track clean and lubed up. So he's soaking that felt with transmission fluid right now.
And it really, that felt holds quite a bit.
Oh yeah. Yeah.
I went over it 3 times and it just soaks
soaks
it right
it up.
in. So the first 3-4 times you soak it, you'll probably pull it off like I just did. Once it gets saturated, you can just kind of maintain it through the top and just
okay.
squirt it in there.
Yeah.
But it holds quite a bit. So these white wipers, they'll kind of wear down as they run back and forth on this round bar, but they'll wear to the same radius as the bar, so you can just loosen this thumb screw, let that white wiper drop back down to the bar, and then tighten it back down. It's slotted, the white wiper slotted up here vertically.
I saw that.
So we'll work our way up a little bit. So we have 2 different scales here, and then this orange bracket is going to be our blade height indicator. So this long skinny one in the middle here is referencing our blade to the bed rails to our standard scale. This one back here that has the 8, 6, 5, and 4 is going to be a quarter scale. So 4-quarter lumber is going to produce you a 1-inch board. That's going to be 1 1/8" drop. 5-quarter is going to be 1 1/4. 6-quarter will be 1 1/2, and then 8-quarter will be 2-inch board. So 4-quarter drop will produce you a 1-inch board, but it is not a 1-inch drop. It's actually an 1 1/8" drop to compensate for the kerf of the blade. This particular quarter scale that we're looking at right now is actually a hardwood scale. So this one over here on the outside is double-sided. We can loosen this thumb screw and slide it out of the top, flip it over, and slide it back down for our standard our standard quarter scale. This is actually a hardwood scale. So that 4-quarter increment is actually an 1 1/4" drop, which will produce you an 1 1/8" board. So it leaves you an extra 1/8" for planing. How small? Tiny. How much do you guys want to cut today? Just enough to verify everything works correctly, more or less?
Yeah.
Okay. Yeah,
Pretty much.
That can be fine. You guys brothers? Twins? Yeah. Identical?
Yeah.
Oh, really? You don't know?
I never found out. Paperwork got messed up or something.
I'm an identical twin.
Did it?
And my brother actually works here too. He works in sales. Yeah, we're identical.
They got a beard too?
Yeah.
He's got a beard?
I don't know if he's here today. Let me.
Well, we should get some pictures and two twins together. If he is.
He was in last week. I thought you guys. I wanted to say something earlier. I was like,
Got a question here for you. Dad mentioned. Are these standard height, or is this one like? Do you order this different, or is it just?
from here to here?
Yeah. Are they the
no,
same on all, or are they
yeah.
changed over the years?
No, that's standard.
So even like his old one would have been the same.
2007?
Yeah.
Yeah, same.
It would have been the same.
Yeah, the only difference between this one and the 2007 is going to be these blade guide roller assemblies are a little bit different. This is the updated style, so these are a little bit fancier. Other than that, the only difference is going to be the width of the throat. Since this is a wide head, it's going to be 6 inches
So
wider.
this is wider, but the height is still the same.
Correct.
So you can cut the same thickness of wood.
Yep.
Okay. Well, that answers that question. I guess it looks smaller because it's wider.
Did you have a board? Well, yeah, if you had a 50, you did, yeah. So our engine, obviously it's a brand new engine, so there is going to be an oil break-in period of 25 hours. At that time, you're going to want to change the oil and the oil filter. There is an oil drain hose here, makes it a little easier. So you'll want to do that your first 25 hours, and then after that it's going to be every 100 hours or once a year. There's also an inline fuel filter right here. That's also going to be every 100 hours or once a year. So that'll kind of go hand in hand with your oil changes. It's pretty much a standard alternator. When it is running correctly, it does have a belt on it. You should be putting out about 14.5 volts. So it's pretty easy to check that. When it's actually running, you can just check it right here to here if you had a meter.
It's a big one.
Yeah. This clear hose here is the one coming from our lube tank on the top side over there. We use a hydraulic tensioner here, and this is what actually tensions our blades. So I'm just going to back this handle out. So this tensioner is kind of an L shape, so it shoots in through to the inside of our pan housing, and then it shoots towards me. And you can kind of see the other end of it. It's right here between these two chrome rods. You can see there's a piston extended out. So I'm going to push this in, and it's going to collapse that piston. So now when I rotate this clockwise, you can see it's pushing this whole idle shaft housing out towards me. That's how we're going to create tension on our blade. So this whole housing here with these two chrome rods should be moving in and out nice and smoothly. So you'll want to keep some sort of a lubricant on there. You could even use the ATF just to make sure that there's no rust buildup, surface rust on here, or pitting of the chrome rods. If they drag as they go in and out of this main tube here, you'll get a false reading on your gauge. So you want to make sure that's sliding in and out nice and freely. So as far as our tensioning goes, we have increased the poundage on that. So we want to be right around 3,000 pounds on this tensioning gauge here.
Wow.
When we have a blade on.
That's a lot.
Yeah. Yeah, so that's went up a little bit in
Yeah.
the past 10 years or so. It was 2,500.
I wouldn't have thought it'd been that much. a lot of poundage. I mean, I wouldn't have even thought 2,500 like you were saying.
Yeah, it's some poundage on there. So this idle side here is just going to be along for the ride more or less. So it slides in and out, and also just free spins. The bearing on this one is sealed. So really the only maintenance to do on this side would be to inspect or replace this wheel belt periodically. So this is a B57 flat tire wheel belt. You can see these are specifically made for us, so they're truly flat on top. You can pick up wheel belts from auto parts stores, but if there's any kind of a crown to it at all, your blade won't track right and it's just going to shoot right off the wheel. So we recommend getting these from us. So these have about a 400-hour life expectancy. Of course, if you have a blade break or you hit something in your log and your blade breaks, typically these take the most of the force or trauma. But we do want to rotate these from side to side about every 50 hours or every 3 blade changes. However you can keep them flip-flop. So that side over there being the drive side takes all the torque of the engagement of the blade. So that wheel belt's going to wear out sooner than this one.
When you move them from side to side, do you also flip them around?
Mm-hmm.
Okay.
Yep. So we'll do that just to try to keep them wearing evenly. And then also you'll want to check in the V groove of this wheel, and just to verify that you don't have any wet sawdust built up inside of there, because that will throw the wheel off balance. The Barker, yeah, they are a little bit loose fitting.
Okay.
And that's to allow the sawdust to escape. Yeah. And something else I'll point out, you can kind of see, even with my hands pressing down, you got about 1/8 of an inch of belt sticking up above this, outside of this wheel housing.
Maybe even a little more than that, but yeah.
As they start to wear in, that's going to shrink. Once you get like below 1/16 of an inch, it's going to be time to change them.
Okay.
So what you don't want is your band riding on the steel wheel. So once that material becomes thinner and thinner, you'll know when it's time to change them.
So it's loose enough where you can get it on and off, and then that's also what allows the sawdust to get in there to cake up. Okay.
Yeah.
All right.
This DeBarker has a small travel pin right here. We'll lock it into position when we're driving with it. When you're not locked in, it can just ride right there in that hole. There's also a dust cover over the top of the motor. There is a fan on the top side of this motor, so if you're going to be using it for a prolonged period of time, we'd want to remove this so that it can exhaust the heat. But just for in here during the demo, I'm not even going to take it off. We had a problem with taking them off, and then customers would leave with their machine and they'd get left behind. So we don't even take them off now.
Do we need to take it off when we travel, keep it from blowing off, or?
You can leave it on for travel.
It won't blow off?
It's wrapped around there like 4 times.
Okay.
Go ahead. So this DeBarker, you can see up here, this is going to be our in and out motor. Small belt to a pulley up here, and that's what's swinging it as far as our drive goes. But as I pull on this, you can see there's a spring here. So let's say our log was tapered. I would want the smaller diameter end closest to us and the large diameter further away from me, so that as the diameter of the log grows, as we move down, the spring load of this tension will keep tension on the spring of the up here will keep the DeBarker against our log. If we have the large end down here and it tapers smaller on that end, you'll have to constantly babysit the DeBarker and keep bumping it in and in and in as your diameter grows smaller. So I'm going to go ahead and swing it in, and then we'll open this cover here. So I'm going to go ahead and grab a blade. Well, I guess before I do that, Are you familiar with coiling blades, or anyone that want to see how to coil a blade?
Well, you throw them out and
I can show
Kind
you.
of roll it in on each other or something.
Yeah.
roll it in on each other and catch it and roll it.
Yeah. How about a demonstration on that?
Okay.
So I know how.
There you go. You can get it on video.
Yeah.
Well, I've got one here that's kind of a demonstration
Yeah.
band. There's no teeth on it. So inside of that cardboard box leaning against the toolbox there is going to be a 10-degree blade that's going to be just like this. Great. So to open this, I'm just going to hold it out in front of me and I'm going to drop the top coil towards me. Now what I'm looking for is a figure 8 by itself. So that's not the right one. So it's going to go back on bottom and I'm going to drop the next top one towards me. So now I got my figure 8 standing alone by itself. Now on top I have an X underneath my hand. Whichever one is on top is the one that I'm going to hold them both with. So the one on top is on the right. So I'm going to hold both of these with my right hand. And then I'm going to release the bottom one out of my hand. I'll hold onto it with my left. And then the band will just open on its own. So fold it back up. We're just going to keep some pressure on it. Grab it with an open palm. Bring my arm straight out in front of me. And then down.
All right.
It looks real easy when I do it.
Do it one more time, real fast. Go
Yeah.
go for it again. Let's talk it out.
So we're looking for a figure
Figure
8
8.
standing alone
And
by
if you don't have
itself.
the figure 8, you then put it on the bottom,
Yep, and drop the next top one.
and then the next top one. Okay.
So underneath my hand right now, I have an X.
Yep.
Whichever one is on top, which the one on the right is on top, that's the hand I'm going to respectively
Gotcha.
hold them both with. The closest one to me will be on my left, and I'm just
Grab.
going to drop it out of my right hand,
Yep.
and it'll open on
Yep.
its own.
All right. Do the close one more time.
And then closing it, we could really use anything you had around you. All we're really looking for is something to keep the bottom band from springing up. I'm just going to bring my arm straight out in front of me
Okay.
and then let the band roll down in the middle.
There we go.
Pretty easy.
You can just try that and go crazy trying to.
Well, we got a video how to do it now, so. It's kind of like those sun shields for your car. You start wrapping those around and you can't get it right, and then next thing you know, you just throw the darn thing away.
Yeah. So this is, of course, there's only one in here, but if you buy a box of 5, 10, or 15, they're going to come like this. There's going to be a heavy zip tie on the bottom.
So there'll be 5 or 15 together.
Yeah, there'll be 15
Okay.
blades in here all together
Okay.
like this. It's okay to remove the zip tie off the bottom. You want to make sure you leave the binding clip in the center. So since this is the last one, I'm just going to take this off. But if there was more than one blade in here, that would be left on. So if you're going to use our resharp department, we recommend putting them back in the box like this and get all 15 blades back in there. To put the clip back on, you just kind of bring one side to the other and then slide your clip on there. So whenever you take your blade out of the box, when you're placing it on the machine, you want to make sure that the teeth are facing towards you, and the teeth on the bottom should always be facing towards the right, towards the sawdust chute. That's going to be the direction of our spin. Also, something to note is our blades are laser engraved or laser marked. This is a Turbo 7 blade. So we just recently started doing this at the end of the year, but all of our newer blades that we're producing off the line are all going to have the profile of the blade laser marked on the blade itself. So if you had 4 or 5 different kinds of blades, you'd be able to quickly identify which is which. Slide this in. I like to put it in the bottom first. Then slide it in the top. So now that we have our blade placed on there, it's not tensioned yet. I'm going to feel for the back of the band, and we're feeling for the back of the band to be flush with the back of the wheel, or 1/8 of an inch from the deepest part of the gullet to the face of the wheel. So as long as you stick with the 1¼ inch bands, the easiest way to check your tracking is back of the band flush with the back of the wheel.
You do that on both sides?
Yep. So I'm going to go ahead and put some tension on our tensioner here. So we're going to do that by rotating this handle clockwise. I'm looking for 3,000 pounds. Now that we're tensioning the 3,000 pounds, I'm going to go ahead and put our covers back on, start the engine, and we'll let it warm up for a second, but then we'll track the blade with the engine.
Keep them on.
So whenever we start our engine, before we start our engine, we always want to make sure our auto clutch is in the disengaged position, so down towards the 0. So now you can see as I cycle it over to 1, we now have more lights lit up. If this was a diesel, your glow plug light would be on. So I'm just going to cycle this over to the 2 position, and then it is spring loaded. When I release it, it's going to go back to 1. Okay, so now our blade is tracked. You can see we've already dropped about 500 pounds. So a brand new blade is going to stretch quite a bit right out of the gate anyway, whether you're cutting with it or not, just from the strain being placed on the mild steel. Once you start cutting and that blade warms up, obviously our lube's going to try to keep it somewhat cool. Depending on the wood you're cutting, a lot of the seasoned hardwood and woods that are really hard, you're going to need a lot, because that band's going to get real hot. As it gets hot, obviously the mild steel will expand and you're going to start to lose tension, so you'll want to keep an eye on this as you're cutting. And then at the end of the day, when you're done cutting, you always want to drop the tension all the way down and release the pressure. It will prolong the seals in here as well as your belts and the blade itself. If you leave it under stress all the time, that blade isn't going to last you very long when you go to start cutting with it again. So I'm going to go ahead and turn it back up a little bit. And I'm going to take these doors back off and we're going to see where it's tracking at. So this side still feels perfect. The back of the band's flush with the back of the wheel. If it was not, there is a cant control bolt on the back side. Also, I'll note right here, there's a small welded tab. This pan cover goes on the outside of it. That tab's there to prevent the door from getting into the blade. We've seen a lot of people stick the door on the inside, and that's not right. It should be on the outside. So around on this side here, we have our idle shaft housing. There's a sticker here that's referencing this bolt head. This is our cant control bolt. So by adjusting this bolt, pitches the idle wheel shaft. And by adjusting that shaft, it pitches that wheel, which changes our tracking. So this one here is actually a fully threaded bolt going through a hole that's threaded in the shaft. So this one's actually extending through the shaft. And then as we rotate this bolt, the threads will either push or pull on the shaft. So rotating it clockwise will pull the shaft this direction, which kicks the outside of the wheel forward, and the blade always follows the outside of the wheel. So if the outside of that wheel goes forward, so will the blade. And then obviously counterclockwise is going to do the opposite. It's going to draw it back towards us. So there's 2 jam nuts on the back side of this bolt. You do not need to loosen those jam nuts to make an adjustment to this. Those are just there for preset tension so that that bolt doesn't vibrate itself out. So the only thing you have to do here, if you did need to adjust your tracking, would be rotate that bolt head whichever direction you need to go. Top and bottom are just acting as set screws pressing on the shaft, so it's not needed to make any tracking adjustments. You shouldn't need to adjust top and bottom.
But do you loosen top and bottom before you adjust this?
Nope.
You don't loosen nothing. You just turn this.
Yep.
Okay.
Yep. Just rotate this bolt head right here. The drive side's a little bit different setup. This side feels good as well. So to adjust the tracking on this side, we're going to do it a little bit differently. So this one uses the cylindrical bearing. So to make an adjustment to this side, we're actually going to release the tension of the blade, and then we're going to make adjustments here with our, they're basically acting as set screws pressing on that bearing. So if we wanted to move the outside of the wheel forward towards me, we would loosen this side and drive this side in, and that would pitch that wheel this way, which would in turn bring the blade towards me.
Something
So
should never have to change it.
right, yeah, very rarely. I would say probably 80% of the time, if you happen to notice that your tracking has made a drastic change, it's going to be the wheel belts are starting to wear in the tapered effect. So then it would be time to replace them.
That feels like it's a little bit sticking this side.
Just a touch. It doesn't have to be like perfect.
Okay.
You just want it
The
to
other
be
side,
close.
you can't even feel a ridge. It's right on it. The other side is.
And then this side here, obviously you can't see a bearing or anything because it uses this large cylindrical bearing that has the bath in it. So this one here is not sealed like that one is. And then this cover here has to go on and off from inside of the mast upright. So it's going to have to swing on the inside like that, and then it'll have to be removed that same way. Our sawdust chute is hinged upright right now just for the travel. We can go ahead and lower this down. There is a red inline shutoff valve from the gas can, which is going to be this one right here. This motor is fuel injected, so really that would just kind of be on you guys if you wanted to shut this off while you're traveling, or this is a 5-gallon can here. So now I'm going to go over some of the alignment procedures. There's a tool that comes with this I'll show you guys how to use, and then we'll just kind of go through and make adjustments as needed. Normally pretty good from the factory, but let's see. Okay, so I like to use a hard scale or ruler whenever I'm doing alignment. You could use a tape measure, but I don't feel it's quite as accurate. And then this is a blade guide alignment tool. This comes with the machine. It's going to be inside the large cardboard box there. So this pretty basic. It just slides right onto our blade with the metal clip, so we want to keep it centered on the tool, and then we'll use this to basically exaggerate the flatness of our blade to our bed. So I'm just going to take a measurement from one end of the tool to the bed, and then I'll move the head back, and I'll take a measurement from the other end of the tool to the bed, just to see how flat our blade is the idea behind this. So the first thing we did was we tracked our blade. So the blade tracked well on our wheels. The next thing we want to do is, it's easiest to look from underneath, but we want to verify that we have a gap from the back of the band to the flange wall on these rollers. So if you look underneath here, we have a small gap right here between the band and the wall of the roller. And this one is actually right where we want it at. It's the width of the very first groove, which is roughly 1/8 of an inch. If I slide this metal rule in there, it's
Pretty
just,
close.
yeah, it's just tight. So this is actually 11 gauge aluminum, which is right just shy of 1/8 of an inch. So that's what we want. You can see this side over here, it's not even a 32nd of an inch gap. So I'm going to open that side up. So the blade is tracking well on our wheel, so we're not going to move the blade. We're going to make all of our adjustment from the roller assembly. So I'm actually going to back it up a little bit and create that 1/8 of an inch gap underneath. So to do that, on the back side here, we have 4 bolts pressing on the shaft of that roller. I'm going to loosen 2 of these bolts. I loosened the bottom and one side. You could also loosen the top and one side. You do not want to loosen all 4 of them at the same time, because then you don't know where you were originally. So I'm going to back this hard stop bolt up a little bit to create a gap for my roller to move back. And that's pretty good there. So I'm going to tighten my set screws back. Run my stop bolt back out until it's making contact, and tighten the jam nut. Alright, so now that I have a gap from the back of my band to the flange wall on both of my rollers, the next thing we're going to do is use our blade guide alignment tool. And I always start on the drive side, but it doesn't really matter which side you start on, because we're going to do the same thing on both sides. So now I'm going to roll this head and carriage back and forth. So I'm going to take a measurement from one end of my tool, like this. So right here, I always use the top side of this alignment tool. I'm right at 15 inches on the top side. Now I'm going to roll it forward and see what we get back here. So back here on this side, I'm at 15 and 1/16. I don't know if you can see on there or not, but I'm just slightly higher in the rear than I am the front. So I'm going to exaggerate, but our blade is sitting like this.
Yep.
By 1/16 of an inch. So now I'm going to use these bolts on this shaft, and I'm going to lower the bottom one, and then I'm going to drive the top one, which will bring the nose of that roller up and allow the front of the band to come up. So we're only off by 1/16 of an inch, so we're just looking to split the difference. It really doesn't matter what height we use. You could use whatever height you wanted. Right now I'm using 15 inches, but the only thing that's important right now is that I'm getting the exact same measurement from one end of my tool to the other end of my tool. That's the only thing I'm trying to accomplish.
And a 1/16 is enough where you would want to make this adjustment.
Yeah, as a 1/16 is going to be our overall tolerance.
Okay.
So, and that's combined from both sides. So this one, let's just say, was down a 32nd in the front, and this one was up a 32nd. Combined, you're a 1/16 out of plane. So that would be our maximum tolerance.
What would you notice cutting if this wasn't adjusted right? Just the wood would...
So the way this one was, it was slightly pitched down in the front. So it probably would have cut flat in softer woods, but if we were cutting something, a harder wood or even pine to where the knots are really hard, as soon as that blade that kind of angled downward were to hit a hard spot or a hard knot, it would have deflected and went around it rather than through it. So
does that also cause it chatter, or like, you know, where you see the
waves on top? So the chatter is normally from not feeding fast enough.
Okay.
If you cut too slow and there's not enough back pressure on this, it'll just sit there and kind of chatter in there.
Okay.
Let's see. right in just a touch over 15. Let's see what this one is. There's looks like there's quite a bit of grease on
Yeah.
here too.
So watch
Yeah,
your
make
coat.
sure you don't set your arm in there. Go just a little more. That's it right there. There's a 32nd over 15. And yeah, still got 15 to 16 here. Yeah. Just a touch more.
I think by you taking time and doing such precise measurements on this part, it kind of emphasizes the importance of it.
Yeah,
You know?
this alignment procedure that I'm doing right now, you'll really only do about every 1,000 hours unless you see a problem before that.
Okay. Gotcha.
Yeah, this isn't something you'll do like between blade changes or anything like that.
Okay. Maybe after a break-in period, it might be good to check it anyway, huh?
Yeah.
Stuff's gonna settle in.
Yeah.
Yep.
This side's actually good. It doesn't even need adjusted. So that's basically the purpose of this tool, is just to make sure that our blade is nice and flat. Once we have our blade flat, now we're going to check for our head tilt. So this is a cantilever style head, which just means that this idle side is free floating. So with this design, the idle side of our head should be a 1/16 of an inch higher than the drive side of our head. So, and on that note, this is a wide head. So when this was proven in the design, it was with the original heads like what he had prior. So whenever we take this measurement, we're not going to come all the way out here because this head is 6 inches wider than the normal one. We're actually going to come beneath our debarker and measure in. So I'm going to go, and now you really just want a point of reference. I always use a down tooth. So all of our blades are going to use a three tooth set. So there's going to be an up tooth, the neutral or raker tooth, and then a down tooth. And I always use the down tooth because that's going to be the bottom of our cut. So right here on the drive side, I'm right at 15 inches on a down tooth. And now I'm going to come underneath my debarker and measure, and about 15 and a 32nd. So that's within tolerance. We're looking for 15 and a 16th. So we're about a 32nd shy. So we could do one of two things here. We can make adjustments to our bed rails. They are independently adjustable on each side, or we could adjust our head tilt. I always leave that for last though. So if all of our bed rails are consistent to this one, then we may make a small adjustment to the head tilt, but it could just be that this one rail is a little bit off. So I'm going to bounce over each one of these and make sure that I'm getting 15 and 15 and a 16 on these. Push forward.
Is there a reason you're using the tooth side of the blade and not the back side, or just
I like to use the down tooth
okay?
because that'll be the bottom side of our cut. So
Okay.
right now I could be using the back side of the band or even a neutral tooth,
Okay.
as long as I have a 16th of an inch difference. good. I'm gonna go all the way back down to the other end. Scoot forward towards you just a little more. Alright, so the head tilt here is actually good. If it wasn't to adjust our head tilt, which I should have shown you what the head was down there, we're going to go back down here. So to adjust our head tilt, we're going to do it from this side. So our mast uses 2 uprights. At the base of each one of these uprights is going to be a roller bearing. So there's one riding on the inside of this lower round bar right here. So by adjusting the tension pulling on it is going to be with these. So if I loosen this inner jam nut and drive this outer nut in to draw the carriage tighter, that's going to increase my head tilt. You just want to make sure that whatever you do here, you also do at the base of the other upright. There's going to be the exact same setup as this underneath this box right here. So if I want to increase my head tilt by 1/16 of an inch, I'm going to increase these outside nuts here 2 flats. So you want to make sure you do everything consistently so there's not premature wear on one bearing in comparison to the other. So if I increase this one 2 flats, that means I'm going to do this one 2 flats, this one 2 flats, and this one 2 flats. And that's going to give me a 1/16 of an inch of head tilt. After I make those adjustments and I tighten all my jam nuts back up, you want to physically reach underneath and feel this lower cam follower, and you should not be able to spin either one of them by hand. If you can spin one and not the other, then all the pressure is only riding on one bearing rather than 2. So
Ignorance here. Flats. What's a flat?
on the nut, one
You're
flat.
talking about turning. When you say 2 flats? What does that mean? Turn it.
The flat on the nut,
Okay.
or the point. You could look at a point, or you could look at a flat.
You talking about two whole turns, or just move it?
Not like,
No, 2 flats.
Okay, I got you.
1, 2.
Okay.
It doesn't take very much
Okay.
adjustment.
Oh,
It's pretty
okay.
fine adjust.
All right.
So now we're gonna go back down here. Okay, so right now we're at 15 inches. And that's what that scale shows, that's what this shows. But I want to show you something else. So this AccuSet 2, we can actually calibrate this computer from where our bed is, or from where our blade is from the bed. To do that, we're going to go into manual mode, which we're in right now. We're going to go down to 12 inches. Once we're at 12, we're going to come back to our machine. We're going to take a physical measurement from the down tooth to the bed and ensure that that's where we're at. And we are.
So it's 12 inches, huh?
Yeah.
Okay.
So whenever you do this, you'll take a physical measurement on the drive side from a down tooth to the bed. and we're right at 12 there. If we were not at 12 there, we would make an adjustment to the head, to the height of our head with our drum switch until we physically read 12 inches off of that bed to the down tooth. Now let's just say we're going to leave this at 12, but let's say it said 12 and an eighth. So that would be inaccurate. We're physically measuring 12, but we're reading 12 and 1/8. So then we would go into our configuration menu by pressing the up button. And then the second one in here is going to be calibrate head. So we're going to press that. And then the same button here is going to be set at 12 inches. So in our scenario here, this is actually going to be reading 12 and an eighth. So then we would just press this button. That would change that 12 and an eighth to 12 inches even, which we are. And then we would just save and save. So now we just recalibrated our head position for the computer. So it now knows that it's 12 inches off the bed. So
That's after you take this to 12, right?
Right, yeah.
Okay.
When we're
After you physically measure and move this to 12, then you just set that.
Yep.
Okay.
And that's basically the alignment. Most people don't really use that blade height indicator scale when you have the computer with the digital readout, but
I never did know I had a scale. I never looked at
oh,
the
a
scale.
scale up there? Yeah. So let me make sure this is all tight. So, just a little bit. So the next thing we'll go over is going to be the computer on here. So this computer system has 5 different features on it. So right now we're going to be in manual mode. We know that we're in manual mode because all we have is a readout of our blade position from our bed. Anytime you're in any other mode, there's going to be more information on here than just a dimension. So the most common thing that you're probably going to be using is going to be auto down. So we can press this button and then it's going to tell us set down and that we're on save setting number 1. And right now all of our save settings are just 1 is 1 inch, save setting 2 will be 2 inch, 3 will be 3 inch. But you can adjust them to however you want. So right now we're at 12 inches and our auto down feature is set to 1 inch.